Hello, my name is Rod Kawecki. I'm doing this video to give you some more insight on my theory on faster than light speeds travel. If you saw my last video, a standard theory for faster than light speed travel is possible. For a brief introduction, how's it work? Well, in comparative to relativity, which is an accepted theory, the speed of light is the fastest you could travel. If there was proof that the universe was traveling at a greater rate than the speed of light, then faster than light speed space travel is evident. That evidence comes from Edwin Hubble. The galaxies are spreading apart. The universe is expanding at 42 miles a second. What's that mean? That means that Einstein's energy, which we will convert to propulsion value, his Einstein's speed of light, has been passed, even if it's only 43 miles a second. Now, it's so small of a velocity that the galaxy being pushed apart. How can this mean that faster light speed space travel is possible? It's the energy content of the space field. The content of the vacuum relative to mass and acceleration. How much power does it take to spread apart the galaxies, to push them away from each other at a constant rate? I have made this indictment against relativity, showing that Edwin Hubble universe expansion is embedded in a space field that allows faster than light speed space travel. Why? Because the constant value of the speed of light has changed. The galaxies are being pushed by a force greater than the speed of light. And that force I calculate as approximately 450,000 miles a second. Now we're talking about a new force relative to the force field on the same principles as relativity that allows faster than light speed space travel. That allows you to travel at the speed of light if the universe is expanding at a greater rate than the space field anomaly is greater than the speed of light. I'm going to go on a little bit further about this. We have the anomaly of uniformity in Hubble theory, based on the same principles as relativity, but at a greater rate. How much force does it take to push galaxies in uniform motion, all at the same rate, the same position, same spin? That's a greater force than the speed of light. To make it, I'm trying to make it more simpler, that if something is traveling faster than the speed of light, then that's proof that the speed of light is not constant. If that force greater than the speed of light is constant, then it's the greater force. That greater force is, they regulate as space. but I think it's an anomaly, the same as Edwin Hubble, how he shows that how the galaxy being pushed away at 43 miles a second, there's an unknown anomaly. Possibly a reverse black hole. What would a reverse black hole? Instead of sucking things in, it's pushing things out. The same way that black holes are looked at and in our galaxies, where were the galaxies born from? I wrote in a book on that subject. It's called Why the Universe Does Not Have a Black Hole. Because the galaxies have black holes. They were created from an embedded pod and left behind evidence of where they came from within that black hole, that space. At the same force, see, all matter was created with the same values at the beginning of the universe. No matter what the value in the beginning, they all had the same energy, let's say, of matter. And that's why galaxies leave behind a black hole. But what about the universe? The universe does not have a black hole. We'd be being sucked into it. Or there's a possibility that there's a force behind the galaxies that are in unifying motion is too great to cause it to be to suck up matter or the galaxies, that it keeps it outside. But that doesn't explain the expansion part. The expansion part is the force that is regulating the expansion at 42, according to Edwin Hubble, 43 miles a second. Create a force behind that, and you have about 450,000 miles a second of propulsion force regulated into energy. That much energy. Now, if a gradient force, let's say, of light is pushing the galaxies apart in unifying motion, and the universe is expanding, then there's a greater force than the speed of light. What I mean by greater force, it shows evidence that if a ship in a vacuum, which is zero, ZPE, 0 point energy, 0 point G, 0 point gravity, that if a force exists that is greater than that, then we can travel faster than light. You understand what I'm saying? According to Einstein's speed of light is the fastest we can travel. I went back and researched how light evolved into physics. I've discovered that it was when they were observing the galaxies around Newton time, Aristotle, and they had a lens. They had a lens at that time, which gets into, what's his name, who created glasses and stuff, Isaac Newton. And they were researching, studying the stars, the galaxies, the planet, what they could anyways, Jupiter, all the 9 planets. And they used the spectrum on that. And The spectrum is the light evaluation of what's from in light that's from 0 to the fastest segments, so they can do their research on the planets and stars out there, and what they thought might consist of because of the light spectrum. And that was done in about the 1700s. We have about 3 generations, maybe 4, in the study. Today's era is faster than light speed travel. If there is a force that exists that is pushing things, allowing things to be pushed in the space at a greater force than light, then faster than light speed space travel is possible. In the early 1900s, they thought the speed of light was the only. They didn't know about this expansion. But in the same type of study, Edwin Hubble observed this through the telescope, that the galaxies were being pushed apart at a constant velocity. So when I talk about faster light space travel, I'm talking about the force available that is presented to us, that is spreading the galaxies apart. It is greater than light and has been measured. You take that measurement, 43 miles a second, and convert it to how much the force would be, and I would calculate it to be approximately 450,000 miles a second. And that's at a constant rate, which means that it's happening all the time. It's happening now, it happened yesterday, and it happened the day before. It happened 100 years ago. It will happen, continue to happen until we discover something that is greater than 450,000 miles a second. See, it's strange because we can go into electricity, let's say, force, electricity, and we can correlate that we have a electrical current which goes up and down, positive, negative, positive, negative, positive, negative, in that type of motion, or impress, what do they call it? Pulse, pulsating at certain to create that much energy. Now, 450 is pretty close to half. Do we cut the force of 450,000 miles a second, change it to 500, evaluate how much force it takes, how much energy it takes to make this happen, subtract it from 500,000 miles a second, and then double it and say this is the electromagnetic, or this is the force that is causing the planets to expand away from each other, to be pushed away from each other. Is it greater or is it much greater than the speed of light? This is one of the reasons why I use 450,000, because it's pretty close to the same energy measurements as using the speed of light. So we double it, we find out 43 miles a second can be evaluated to 450,000 miles of force we need to travel faster than light. Or we have, theoretically, we can create. And it's shown evidences in the space. embedded in the Hubble theory, which consists that there's a force greater than exists that is greater than light. So we can travel faster than light. I've written over 13 books. The mobility, black hole. Why does the universe have a black hole? Because it looks more like the Hubble balloon that is expanding everything. Is there an end to the universe? Does time end? Is time travel possible? I'll take a second for that one and by saying that if there's a force greater than light that exists within our universe, then according to relativity, we cannot travel faster than light because we can travel fast. I mean, can't travel in time, but we can travel faster than light. But that doesn't mean that planets are going to start traveling backwards because due to friction. How can a little ship driving around in an empty space, which means there's no energy content or attraction, and change time? I'm not saying that it's not possible, but I don't think that's the direction. And with that, I would say it's not possible. I go into a lot of this. Time travel is beyond me, but the facts are the facts. If there exists a force greater, it's evidence the faster than light speed space travel is possible. How big that force is? How big is a force allowed in a space vacuum before something happens or it's stopped? The vacuum says, no, we cannot allow you to rise greater than that. So is it infinite? These are the arguments. Is it infinite or is it finite? Now, if there's the force that's creating it, it's physical, like Hubble's balloon, then it's possible it could be finite, which means we have a reoccurring fact of reincarnation, the reincarnate universe, which means matter has no place to go. It's in empty space. It's in a vacuum. It's elevated center universe. Center universe, center space, space field, midfield space. It has no place to go. If it burns up, it turns into something else. But the weight and the content don't change. How much the universe does absorb, how much space does absorb in the weight against matter and its existence is beyond me. It's probably beyond all physicists. I mean, how much energy content or matter content is because mass and energy content would be used up just to create this ground force, which is matter has no place to go, no matter what happens to it. Turns into something else. And so we don't lose nothing. How much we do lose, we might lose some of it. I got into that in I think my last book, that what's making the universe expand. There has to be something. Where is it coming from? Is it coming from matter, its existence in this vacuum where we are expanding? We have to, if we're expanding at a constant rate, that energy has to be coming from somewhere. Where and what? I go into that in my last book. What I think could be, what it might be, depending on the elements taken into consideration. Anyways, FTL is possible because there's a greater force that is probable in our estimations towards propulsion and the speed of light. Thank you very much. My name is Rod Kawecki.